Hello one and all, welcome back to my channel. In this video, I will be briefly describing a machine learning algorithm called decision tree. A decision tree is a graph that uses a branching method to illustrate every possible outcome of a decision. Here, each internal node represents the outcome of the test and each leaf node represents a class label. The path from root to leaf represents classification rules. This can be actually represented as a graph. Now, let's understand it with an example. Here, we have a dataset of homes in San Francisco and New York. And the problem statement is to create a classification model and distinguish homes in both the cities. Let's begin with some intuition. Let's say you had to determine whether a home is in San Francisco or in New York. In a machine learning term, categorizing data points is called a classification task. Since San Francisco is relatively hilly, the elevation of home may be a good way to distinguish the two cities. Based on home elevations, data to the right, you could argue that a home above 73 meters should be classified as one in San Francisco. Now let's add few nuances. Adding another dimension allows for more nuance. For example, New York apartment can be extremely expensive. So, visualizing elevation and price per square foot in a scatter plot helps us in distinguish lower elevation homes. Dimension in a dataset are also called features, predictors, or variables. Drawing boundaries, you can visualize your elevation and price per square foot observations as the boundaries of region in your scatter plot. Homes plotted in the green and the blue regions will be in San Francisco and New York respectively. Identifying boundaries in the data using math is the essence of statistical learning. The datasets we are using to create the model actually has 7 different dimensions. Creating a model is also known as training a model. On the right hand side, we are visualizing the variables in scatterplot matrix to show the relationship between each pair of dimensions. And now it's time to build a machine learning algorithm. Finding patterns in data is where machine learning comes. Machine learning methods use statistical learning to identify boundaries. One example of machine learning method is decision tree. Decision tree looks at one variable at a time and are reasonably accessible. Now finding better boundaries. Let's revisit the 73-meter elevation boundary proposed previously to see how we can improve upon our intuitions. Clearly, this requires a different perspective. By transforming our visualization into a histogram to see the distribution, we can better see how frequently homes appear at each elevation. While the highest home is in New York, that is 73 meter, the majority of them seem to have far lower elevations. A decision tree uses if-then statements to identify patterns in the data. For example, if a home elevation is above some number, then the home is probably in San Francisco. So it's a basic simple if and else condition. The value between the branches is called a split point. Homes to the left of that point get categorized in one way, while those to the right are categorized in another way. A split point is the decision tree's version of boundaries. And there actually will be few trade-offs. Picking a split point has a trade-off. Our initial split, that is 73 meters, incorrectly classifies some San Francisco homes as New York ones. Look at the large slice of green in the left pie chart. Those are all San Francisco homes that are misclassified. These are actually called false negatives. However, a split point meant to capture every San Francisco home will include many New York homes as well. These are called false positives. And then the idea is to find the best split. At the best split, the results of each branch should be homogeneous as possible. There are several mathematical methods you can choose between to calculate the best split. As we see here, even the best split on a single features does not fully separate the San Francisco homes from New York homes. Recursions. To add another split point, the algorithm repeats the process above on the subsets of the data. This repetition is called recursions, and it is a concept that appears frequently in training models. For lower elevation homes, price per square foot is at 1061 per square feet. It is the best variable for the next if then statement. For higher elevation homes, it is priced at 514K dollars. Now let's see how a tree is grown. Additional folks will add information that can increase a tree's prediction accuracy. So at the first cut, if the criteria chosen is at price per square foot, the diagram shows the distribution. Splitting one layer deeper, the tree's accuracy improves to 84%. Adding several more layers, we get to 96%. You could even continue to add branches until the tree's predictions are 100% accurate, so that at the end of each branch, the homes are purely either San Francisco or New York. These ultimate branches of the tree are called leaf nodes. Our decision tree models will classify the home in each leaf node according to which class of home is in the majority. Now it's time to make predictions. The newly trained decision model determines whether a home is in San Francisco or New York by running each data point through its branches. Here we can see that the data was used to train the tree flow through the tree, and the kind of accuracy we are receiving is 100%. So this is something which happens on training data set. Because we grew the tree until it was 100% accurate, this tree maps each training data point perfectly to which city it is in. Now let's have a reality check. Of course, what matters more is how the tree performs on previously unseen data. So that in machine learning term is called test data. To test the tree's performance on a new dataset, we need to apply it to the data points that it has never seen before. This previously unused dataset is called test data. Ideally, the tree should perform similarly on both known as well as unknown data. So this one is less than ideal. These errors are due to overfitting. Our model has learned to treat every detail in the training dataset as important, even the details that turned out to be irrelevant. We'll discuss about overfitting in our next video. Let's do a quick recap now. Machine learning identifies patterns using statistical learning and computers by unearthing boundaries in the dataset. You can use it to make predictions. One method for making prediction is called a decision tree, which uses a series of if-then statements to identify boundaries and define patterns in the data. Overfitting happens when some boundaries are based on distinctions that don't make a difference. You can see if a model overfits by having test data flow through the model. So that is it about this video. Please subscribe our channel to keep looking for our next videos. Thank you.